A very good day for all of you. So today we will continue with our lecture on pneumatics. So today we will see another topic which is very important. We call it as cascading method. So cascading is actually a way of you simplifying a circuit in order to draw your circuit effectively and simplify your circuit. We have two ways of drawing. One is cascading method. Another way is by using step counter method. So today we will particularly will see cascading method. So before we go into the drawing of the circuit, we will see some definition. So cascade is actually a definition, a series of stages in which the output of one stage is the input of the next stage. So meaning you have a few stages. So each stage will have input and output, and based on the definition is saying that the output of the first stage will be the input for the second stage. So that is what we call as cascading. So cascade method is simple to apply and result in a reliable and easily understood circuits. Okay, so we will, as you can see here, so we have one stage cascading and two stage cascading, and normally we will have three stage cascading. So in one stage cascading you will have two groups, group 1 and group 2, and you have one group changing valve and also two inputs, input for group 1 and input for group 2. And for two stages you will have three groups, group 1, group 2 and group 3, and you have two group changing valve, and you have three inputs, input for group 1, input for group 2 and input for group 3. So for three stages you will have additional, so you have four groups, group 1, group 2, group 3 and group 4, and you have three group changing valve, 1, 2 and 3, and you have four inputs. Okay, so this is how the layout of group cascading method will be. Okay, so we will demonstrate some of the cascading methods. Okay, in order to develop control circuitry for multi-cylinder application as done before in classic method, it is necessary to draw a motion diagram to understand the sequence of actuation of various signal input switches, limit switcher and sensor. So practically you have a few steps that you need to follow. So we will see each step. Okay, step 1, you need to write the statement of the problem. So this is a simple statement. So it's only for two cylinder. The two cylinder. The first cylinder is name A. Extend and bring under stamping station, which where cylinder B is located. Okay, so you have clamping and also stamping. So this is a simple application. So you place your material here and you will have cylinder A to clamp it while cylinder B will stamp it. Okay, so you have the sequence mentioned in the statement. Okay, that will be the first stage. Then you go to the second step. So you draw the positional layout. So this is your positional layout. Then step 3, so you need to represent the control task using notational form. Okay, so if cylinder A advance, that means the notational form will be A plus. Okay, if cylinder A retract, meaning the notational form is A minus, and cylinder B extend is B plus, and cylinder B retract is B minus. So this is a simple notational representation. Okay, for the given application, the sequence will be A plus, B minus and A minus. So this is the sequence. Okay, the sequence for clamping and stamping application. So meaning cylinder A extend, then cylinder B extend, cylinder B retract and cylinder A retract. So that is the application. Okay, then you move to step 4. Step 4 will be displacement step diagram. So you have a displacement step diagram. So you can see each step will have only one cylinder extend or retract. So cylinder A extend, cylinder B extend, cylinder B retract, and cylinder A retract. So that is the sequence given. Then we move to step 5. So draw the displacement time diagram. So here the time is not really mentioned. So you can just put T1, T2, T3, T4 and T5. So the operation will be the same. Then you move to step 6. Analyze and draw pneumatic circuit. Okay, so analyze, you have few things that you need to analyze. First you need to analyze what are the inputs. Okay, so for cylinder A you have two inputs of in form of roller limit switch. Okay, to check whether your cylinder A in ohm position or the retractor position. So you have A0, and this is not ohm position. Extended position will be A1. Then for cylinder B, so the ohm position or the retractor position will be B0, and for extended position it will be B1. So meaning you have four roller switch to give inputs. And for the output, forward motion of the cylinder, so you already know it's A plus, so return motion is A minus. uh, Forward motion for cylinder B will be B plus, and return motion for cylinder B will be B minus. So that's the output signals that you will get. Okay, we are already analyzed input signal and also output signal. Then we move to step 6.2. You connect all the inputs and output signals to your displacement time step diagram. Okay, so this will be your sequence, so you can read. So usually your start signal is also required along with A0. So meaning your circuit will check whether A0 is present, meaning cylinder A in the retractor position, and you have your start signal using a push button. Okay, so meaning both must be present to start your circuit. Okay, then A plus action generate signal A1. Okay, so this will be your stage 1, and this output of your stage 1, which is signal A1, will be input for cylinder B to extend. Okay, so this is what we call as cascading. So you have various levels, okay, various stages that will cascade. Okay, and you can see, so this is your final uh, motion diagram. So you can see here, so you have A0, okay, from the previous loop, so meaning your cylinder already in the retractor position. Then it comes together with start. Okay, so if both present, then your circuit will start. Okay, so here it will be A0 still, okay, together with start. Then your cylinder extend, okay, cylinder extend, and it will hit A1, okay, meaning cylinder your sensor A1 will active. Then it will have B1 to extend, okay, your cylinder B to extend and it B1. Then it will change the group, then B0 and A0. So you don't need to worry about this. Later we will see an example how we can draw this step by step, and also this. Okay, so you relate with your displacement step time diagram. Okay, then at the end you draw your power circuit. Okay, so we can see uh, we can divide this operation into two groups. How we can divide? So you have A plus, B plus, B minus, and A minus. Okay, so you only can divide this into two groups, because in each group you cannot have two same element. So meaning A plus and A minus cannot be in same group. So you since we only have two cylinder A and B, so you can only have A plus and B plus, or A plus and B minus, or okay, so it cannot be from a same group. Okay, so for this example, for group 1 we take A plus and B plus, and for group 2 B minus and A minus. So it's always advisable to place all the positive in one group and negative in one group, so provided it's not overlapping. So normally it won't overlap. So in case your application have 3 cylinder, so you can place A plus, B plus and C plus in one group and minus in the second group. Okay, so that's how you can divide the group, and you choose a group changing valve. Okay, we will see this in the next example. Okay, then you can draw the circuit. Okay, so this will be your circuit designed using a cascading way. So cascading way, you can see you have 2 groups, then you have a group changing valve, so you have the actuators and all the inputs. Okay, so this will be your input. You have 2 conditions. A0 is stack and also your push button. So then you have a group changing valve to select the groups, and also for the actuating valve to actuate your cylinder. Okay, we will see a short example. Okay, so this is a example of a drilling machine. Okay, we read this. A pneumatic actuated drilling machine contain of 2 DAC. Okay, so we have 2 DAC to control 2 cylinders. When the workpiece is located at its position, cylinder A will climb the workpiece. Okay, so we have a cylinder A here. Then the drilling process is started. So you have a drilling, so meaning your cylinder B will extend to drill the workpiece, where the cylinder is controlled by cylinder B. After finish drilling, cylinder B will retract to the initial position before cylinder clamping cylinder retract. So this operation will be almost similar like the previous description that we have seen. Okay, so how you can draw? First, you define the motion. Okay, so the motion will be A plus, B plus, B minus, and A minus. Okay, similar as the previous example. So this motion will follow what is mentioned in your narrative, or the description given in your question. So based on this previous slide, so we have known that cylinder A extend first, then cylinder B extend, then cylinder B retract first, then only cylinder A retract. So this is the motion that is mentioned. Then you can divide it into group. So as I mentioned earlier, you can divide this into 2 groups. Okay, so you normally I advise you to put all the positives in one group and negative in another group to avoid confusion, and at the same time you can put a plus and B minus in a same group. Okay, provided so the element is not repeated. So what it means, so A plus and A minus cannot be put in same group. Okay, or B plus and B minus put in same group. It must be a different alphabets. Okay, so in this case, so A plus and B plus. Okay, then third, you move to limit switch status. So you need this in order to understand how the circuit works. Okay, meaning you start with your push button or start button. So start button condition you must accompany it with A0. So meaning A0 is active, actuated, meaning on. Then you have your push button, then it start the circuit. Okay, if the cylinder A is not in the retractor position, even you press the start button, it will not start. Okay, so these 2 conditions are required to start your circuit. Then it will move once you push your start button with A0, then your cylinder A will extend. Okay, cylinder A extend and it will hit your roller switch A1. Okay, then cylinder B extend. Okay, so this is your group 1. Okay, then you need to, in order to go to the next sequence, so you need to uh, change the group. Okay, when the group changing valve will active, so once cylinder B extend and hit the B1 switch, okay, then your group changing valve will active, then it will start your group 2 operation. Okay, so once the group changing valve is uh, activated, so the group is changed, then B1 will automatically retract. Once it retract, it will hit B0. Then once it is B0, your cylinder A automatically retract. Okay, once it retract, it will reach A0, where a complete cycle is achieved. Okay, so then we go to number of connecting lines. So meaning how many connecting lines will be drawn in your cascading circuit. So it's equals to number of group. So let's say your group you have two, so you need two connecting lines. Okay, so this is number 4. Then you want to determine how many group changing valve is required. So the formula to calculate the number of group changing valve is actually number of group minus 1. So meaning you require only one group changing valve. Okay, so we move to drawing the basic circuit. So you have a few steps here that you need to follow. Step 1. Step 1, you draw the actuators. So in this case you have two cylinder, you draw the cylinder. Okay, first. So this is a double acting cylinder, so you draw the double acting cylinder, and each cylinder will have its particular directional control valve. So it's a pilot operated. Okay, so you have two. So this is 5 over 2 by double pilot operated DCV. Okay, so you draw this first. This is the step 1. Then you draw connecting lines. So you have two connecting lines. I always draw group 1 on top and group 2 below. Okay, so you already have this group 1 and group 2. Then step 3, so GCV is group changing valve. Okay, so you have one, based on your calculation in the previous step, you have one group changing valve. So you draw this, and this is connected to in this similar way. Okay, so your this side is connected to group 1 and this side is connected to group 2. So this is a initial setup on how you draw the basic circuit. Okay, so we move to the first step. Okay, first step, we already know from your motion diagram that in order for a cylinder A to extend, so you need to have input from start. So ST is start button or push button plus with A0. Okay, so how you want to draw this in your circuit? Okay, for this operation A plus, so you need to draw from input until the output. Okay, so these two input will yield in A plus. Okay, so this is your push button, okay, or start button, and A0. Okay, A0. So A0 you need to connect with the surface. So meaning this is on. Then when you press the push button and this is on, you have an input to group changing valve. So once you have the input on your left hand side, the group changing valve will choose the left hand side. Okay, and this line will be transferred to left hand side. Okay, then you will have input going through here to the first line, group 1, and then so this DCV will be connected to group the connecting line group 1, G1. Okay, then you have here is connected to your cylinder. This is some sort like how we study in the previous chapters, and you have here A0, A1, B0 and B1. Okay, so this is a complete circuit. So once this circuit is achieved, your cylinder will extend. Okay, so this operation is already achieved. So this is your first step. Okay, then we move to second step. So meaning once A1 your cylinder extend and each roller valve A1, your cylinder will B will automatically extend. So where you want to put A1? So A1 you put in front as a input for cylinder B. Okay, so you have a roller switch here, and then it become input for your directional control valve B, and then your cylinder extend. Okay, so this is a much direct operation. So you place your A1 at the entrance of your DCB B. Okay, so the rest does not change. So this will be all the same. Okay, then we move to the third one. Third one is a bit different. So once your cylinder B extend and it B1, okay, B1, then you need to change the group first. Because in group 1 it's only A plus and B plus, and in group 2 it's B minus and A minus. So if you want to achieve B minus, you need to change the group first, okay, from group 1 to group 2. Okay, how you want to achieve this? So once your cylinder extend and reach B1, so you need to change the group first. So B1 you put before the group changing valve. So you put your B1 here, then it become an input for group changing valve. You change the group first. Okay, once you change the group, okay, so you have here this the returning. In order for you to return B minus, cylinder B to return, so you will need to connect it to right hand side of directional control valve. So this is connected to group 2. Okay, then once this line is achieved, it will be automatically retract the cylinder B. Okay, so this operation is achieved. Okay, once this is achieved, you move to uh, the last operation, which is A minus. So in order to achieve A minus, you need to give B0. So once the cylinder B retract, it will automatically hit B0. Then you need to have A minus. So B0 you place at the entrance of the right hand side of DCV A. Okay, so once it hit, it will give input to directional control valve A to retract your cylinder. Okay, so you already settled this full operation A plus, B plus, B minus and A minus using a cascading way. Okay, once you've already finished this, you have few more steps to go. You need to remove all the excess line. Okay, so you need to remove the lines. So once the excess line is removed, so you can have a much cleaner circuit. So this is a much cleaner circuit. So initially it was an excess line at the back and this side. So all the excess line you can remove, and all the groupings of the connecting line you can remove. So based on this, so this is your final circuit. Okay, once you finish that, you can replace the compressed air symbol at the beginning of the circuit with uh, 0Z and also 0S. Okay, as I mentioned in the previous circuit. Okay, but in fluid sim, so you will achieve this similar circuit, okay, as I shown in the slide. Okay, so this will be the transmission line. So meaning, so you already have A0 and you have pressed the push button. So blue line is connecting line for group 1. So you can see all the inputs are connected, and the red line is your group 2. Okay, so I think that's all from me. So this is how you can do a cascading way of settling your pneumatic circuit. So I encourage you to try few questions. Okay, if the similar question you can try by grouping A plus and B minus in a similar group. Okay, and vice versa, as long in the same group you don't have a similar symbol. Okay, you can try few more examples. We have examples in the lecture note and the synchronous class, so you can try that using this cascading way. Okay, for next week we will see how we can solve the similar question using step counter method. So thank you and all the best.